Welcome, Geometry iPad Initiative students. This is Mr. Lane coming at you live from his living room. But anyways, this is the objective. Students will prove and apply properties of parallelograms, and students will use properties of parallelograms to solve problems. You can read through the why yourselves. Make sure you answer number 5 in your notes. Be looking for that secret word today. No hints that it's a bird. Pretty feathers. It will come later. Alright, use properties of parallelograms. A parallelogram, let's go ahead and define it. A parallelogram is a quadrilateral. Hopefully you remember quadrilateral is a four-sided figure with both pairs of opposite sides congruent and parallel. Alright, so that's your definition. Only one definition today, so that's not too bad, but we do have about 4 theorems in here. So make sure you take notes over those. The first 2 of them is a quadrilateral is a parallelogram, then its opposite sides are congruent. The second one is if a quadrilateral is a parallelogram, then its opposite angles are congruent. So notice on both these pictures we have opposite sides marked congruent here. That's going to make this quadrilateral parallelogram. And if the opposite angles are congruent, then that's going to be a parallelogram also. Alright, let's see here. The third theorem is going to be if a quadrilateral is a parallelogram, then the consecutive angles are supplementary. So that means that x and y here would add to equal 180, or this x and y here would add to equal 180. Doesn't matter which pair of consecutive sides, remember consecutive right next to each other, any one of those 4 circles is going to add up to equal 180 degrees. Alright, and the last theorem here is if a quadrilateral is a parallelogram, then its diagonals bisect each other. So we've got the diagonals drawn in here, and then notice that we have the markings to put that M would be a midpoint of both QS and PR. Alright, we got the first example right here. We've got find the measures of angle FG and H, then find the length of FG. I think I'm going to work backwards here on this one. Looks like FG is right here. We know that this is a parallelogram from the markings of the parallel sides. So if this side is 8, the opposite side is going to be 8 also. And then let's see, if this is 60, then the opposite angle is going to be 60 degrees. And then these are going to be supplementary, so that's got to be 120 degrees to add up to equal 180. And then whichever one we want to go from to add to equal 180, we'll say this 60 plus 120 will equal 180, and so we got all 3 of the angles marked. Alright, find the measures of each parallelogram. Find each measure in the parallelogram JKLM. So we want to find all 4 of these things that are right down here marked for us. Let's see, we got in M first. Well, we know that the diagonals bisect each other, so if Kn is 2, we know that Nm is going to be 2 also. Alright, Km would be the full length across, so if this is 2 and this is 2, all the way across would be 2 plus 2, which is 4. Angle JML is this big angle right here. Well, we've got the consecutive angle to it as 110, so what adds to 110 to equal 180? And that's going to be 70 degrees. And then we got one more angle here, which is KML. Well, the diagonal is going to bisect this angle here. I'm sorry, that diagonal does not actually bisect that. We've got a 30-degree angle right here. We know that the entire one is 70 degrees. So what's left over out of the 70, if we take away the 30, that would be 40 degrees. Alright, let's move on. Regular geometry students would be doing these problems from the page. iPad Initiative students, your problem should be up, ready to go on your assignment. Alright, use the properties of parallelograms. We're supposed to find x and y. Notice that we now have some expressions that we're supposed to set up an equation for. First off, the y is going to be very easy because opposite angles are going to be congruent. So if angle C is 65 degrees, then angle A is also going to be 65 degrees. So that's going to be our y. And then we need to set up the opposite sides are going to be congruent. So we got x plus 4 equals 12, making a real nice, easy problem to solve for x. We got to subtract the 4 from both sides, which they'll add out, and x will equal 8. And bada boom, bada bang, we're done with that. Let's move on. Alright, in parallelogram ABCD, now let's draw a little picture here real quick. Let's see, A, B, C, D. We got AE is y. We got EC is x plus 3. We got BE is 2y. We got ED as 3x minus 1. And we're supposed to find the values of x and y. So we've got to set up a little equation here. We know that the diagonals bisect each other, so we got y is going to be equal to x plus 3. And then on the other equation, we're going to end up with a system of equations here, so hopefully you're caught up on your algebra. We're going to have 3x minus 1 is equal to the other half there that is bisected, which is 2y. So we're going to use substitution on this one to solve. Because we have y solved for in the top equation, we're going to substitute what y is equal to into the bottom equation. So we're going to have 3x minus 1 equals 2, and then plugging that in is going to be x plus 3 into the parentheses, which takes the place of our y. So we got to distribute that 2, so we'll get 2x plus 6 is equal to the 3x minus 1. So we're going to add the 1 to both sides and subtract the 2x at the same time. So we'll have x is equal to, looks like 7 when we add the 1 to the right hand side. And we now know what x is equal to. Well, if we plug the 7 into the first equation right here for x, then all we'll have is 7 plus 3, so y then would equal 10. Alright, let's move on. Alright, a little easier one on this go around, it looks like. Again, opposite angles are going to be congruent, so we're going to put 2x is equal to 50. If we divide by 2, we'll have x is equal to 25, and we're done with the x part. And then we got opposite sides are going to be congruent, so the 18 has to equal the y plus 3. So subtract the 3, and 15 is going to equal the y. Alright, that one was a lot easier. Let's move that box. That's the problems for the regular geometry students. We'll go ahead and move on. Alright, we're almost done with this. I think we got about one more problem, so I'm going to go ahead and give away the secret word. You guessed it, pretty bird out there. It's the peacock. Maybe someday I'll have a wedding or something with peacock themes. That'd be pretty cool. But anyways, we're a little sidetracked here. I think I got a parallelogram to graph for you here. So we got A is at 1, negative 2. Then we got negative 2, 3 for B, right there. And then we've got 5, 1, 2, 3, 4, 5, down 1 right here. And we've got to figure out where the other vertex is so that this would be a parallelogram. So I'm going to go ahead and mark what we know here. So C is going to be somewhere right over here in this range is kind of what we're looking at here. So how am I going to figure that out? Well, probably the easiest way is we know that this side has got to be congruent and parallel to the opposite side. So if I could go from the endpoint the same slope and the same distance, then I would actually have C without doing a whole lot of work for it. So I'm going to count a rise of 1 and a run of 1, 2, 3, 4, and we're going to mark that from this vertex up here. So we're going to go up a rise of 1 and a run of 1, 2, 3, 4. And we're going to go ahead and put that vertex right there. Alright, so now we should have our parallelogram. and it's wanting to know the coordinates of what C is there. So we're going to list that out real quick after we count. So that's 1, 2 for the X, and up 1, 2, 3, 4 for the Y, and we're done. Alright, regular geometry students, there's your problems. A little summarization here, might not be a bad page to take a screenshot of. Put in your notes real quick. There's the up one, down ones for the lesson. If you had boxes, here they would be. Good luck on those. Kind of frozen up, so I guess you don't get to see the boxes this time. So moving on. All right, this is Mr. Lane signing off from OHS High School. Have a good day.